Welcome, ladies and gentlemen, to a Khan Academy's tutorial on simplifying rational expressions using a common monomial factor. Here we go. Just go ahead and get right into it. Giannis and Shota manipulated the rational expression, and there you see it. The responses are shown below. Okay, so we have Giannis's answer and we have Shota's answer. Okay, which student wrote an expression that is equivalent to the original expression? What do we have to do here? Well, we need to look at the original problem and see if we can factor the top and bottom. Okay, so we're going to take a look at this and we'll see if we can factor it. So we're looking for common factors. Let's start with the top. Common factors between 16z squared and 40z. Okay, right away I'm thinking first of the coefficients. So the coefficients we see are obviously 16 and 40. Common factor between those two is 8. 8 is the greatest common factor. Now, technically 4 and 2 are also factors. We want the biggest one. Now, let's look at the variables. We have z squared and z. We want to take the smallest one that fits into both. Well, that's z. Okay, they're the biggest one that fits into both. Z squared doesn't go into z, so usually you always take the smallest degree of the variable if it's common among multiple terms. So we're going to factor out 8z. What's left inside? Well, we're going to take 16z squared and divide by 8z. We get 2z. And then we have negative 40z, so we're going to keep the minus. Negative 40z divided by 8z, that gives us 5. 5 times 8z gives us negative 40z. And just so you see that, I'm not going to do this again, but I want to show you the first part. We're going to do 16z z squared divided by 8z, and that's where we got that first 2z answer. And then for the negative 5, we got negative 40z divided by 8z, and that gave us negative 5. So that's where that came from, in case you're wondering. Okay, that's the top. Now we have to do the bottom. So the bottom, we'll use, what color? We'll use this purple. So we want to use this color. Now we have to find the greatest common factor between these ones. So let's go ahead and start. We'll factor out, we'll do green again. So what are the common factors between 24 and 40? Again, it's 8. I think that's the biggest one that goes into both. So we're going to factor out an 8. And then take a look again. Here we have a common factor of z for both of those. So we're going to factor out a z and what's left inside. This time I'm not going to show the division like I did here and here, but that's the process we're using. We're dividing each one of these by the greatest common factor, which is 8z. So 24z squared divided by 8z gives us 3. 24 divided by 8 is 3. Z squared divided by z is z. Minus, we're going to keep the minus sign. And then 40z divided by 8z gives us 5 again. It's the same thing, so we're going to get 5 again. Now, we can cancel here. This is the whole point. We can cancel because we have something in the same in the top as in the bottom. So we cancel that out, and we're going to be left with 2z minus 5 and 3z minus 5, which is Shota's answer right here. So it's only Shota that did this correctly. So we're going to circle only Shota. All right, next question. 3 more. We'll hopefully get the gist of it now. What we're looking to do is factor and then cancel. So let's go ahead and look at the next one. Okay, top is simplified. Can't do anything more with that. Bottom, we can go a little bit further. We have to find a common factor there. Let me switch gears. Let's go to red. And 15 goes into 60. 15 times 4. And then the biggest factor between x cubed and x to the 4th power is x cubed. What's left inside? Well, what's left inside is going to be x, because 15x cubed times x gives us 15x to the 4th, minus, and then 15 times 4 gives us 60, and then it's already x cubed, so we're done. Now, can we reduce here? Oh, which values of x make the expression undefined? So here, this is what we're doing. This is the other part of this. If we have an expression like this, and we have x in the denominator, which we do, we have x in the denominator there and there, 2 different spots. Okay, let me change this. I want this parentheses bother me. There we go. So if we have x in the denominator, we have to consider, okay, if we plug in a value for x, will it make the denominator go to 0? 6x cubed divided by 0. Why is that a problem? This is a problem because this is undefined. When you divide by 0, it's undefined. So we need to know, okay, we have to be mindful of which values will make it go to 0. Here we have a parenthesis, this whole parenthesis, x minus 4, we want to know what values will make that go to 0. So we add 4, we're solving for x here, x equals 4. That means if x equals 4, this whole problem will be divided by 0, which is that is a problem, okay? So x equals 4 makes this go undefined. Also, if we plug in 15x cubed equals 0, because these two are multiplied together, these two terms are being multiplied together. So we want to know 15x cubed, what will make that go to 0? So we divide by, oops, wrong marker again. We divide by 15, we get x cubed equals 0, take the cubed root, and we get x equals 0. So we have two answers here. We have x equals 4 and x equals 0. So we choose all that apply. 4, 0. What's wrong? Oh, I have to simplify it first. Oh my goodness. They're making me do a lot here. So we're going to simplify this. Let me rewrite this. So we have 6x cubed over 15x cubed times x minus 4. We're going to cancel out what we see in the top and bottom here. Now, it's very important that we're going to find what makes the expression undefined before we simplify. So even though we're canceling now, it's good that we found that x could equal 0 to make it undefined and x equals 4 before we canceled. So now we have, we can also cancel this and this because they both have a common factor of 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So we have 2 over 5x minus 4. So we're going to type that in for the simplified expression. What was it? 2. Let's do 2 in the top, and then 5 times x minus 4. Not 44. Bugger. Okay. And then we know that 4 and 0 make it go undefined. That should be good. All right, next question. There we go. Simplify the rational expression. So first thing we're going to do is simplify. You see a lot of 5s here. So it should be obvious that we need a factor out of 5. Notice how we don't have a z in the denominator too. That's good news. That means nothing will make this go undefined because there's no value that we can input. It's just divided by 5. So nothing will make this go undefined. We're going to factor out a 5 in the top. What's left is z plus 11, and then over 5. We can cancel here the 5 and the 5, and we're just left with z plus 11. Z plus 11. Okay? Which values of these makes the expression undefined? There are none. No values make this go undefined. And we're done. Last one. Takumi and Kaliska manipulated the rational expression. Okay, there it is. Their responses are shown below. So we need to do this also. We need to simplify this. Let's look for a common term here. I'm going to factor out a negative. I see lots of negatives, so I'm going to factor out a -3 in the top. And then also a y, because there's a y in both terms. So I take the smallest degree of y. What -3 times what gives me -9y squared? That's 3y. And then plus 1. -3y times +1 gives me -3y. Again, what we're doing is we're taking these two terms and dividing by the GCF, which is -3y. In the bottom, we can also factor out a -6y, actually. And we're left with y plus 1. Now we can do some simplification. I see here. Well, first you should notice that Takumi wrote exactly what we just wrote there. Okay? The response is shown. Which student wrote an expression that is equivalent to the original expression? Okay, so this guy, Takumi, he wrote it in the same way we wrote it. Okay? But are we saying Kaliska is wrong? No. Kaliska is not necessarily wrong. Notice how instead of taking out the greatest common factor, Kaliska, what this person did was take out 2y. Why would they do that? Why would they do that? Well, they wanted the same thing in the top. No, they took out a 3y because they wanted to cancel this 3y. Okay, so if they saw, sometimes it's a good strategy. If you saw the factor in the top that you took out was a 3y, they want to do the same thing in the bottom. So they took out a -3y, and what they got was 2y plus 2. -3y times 2y gives us -6y squared. -3y gives us times 2 gives us -6y. So now the whole point of doing that was canceling -3y and -3y, leaving us this, which is the same as what Kaliska wrote. So both of these people are correct, both Takumi and Kaliska. And we're done. Done. There it is. hope you enjoyed this video. Hope you got 100% like we did here. And I look forward to seeing you next time on Wesley Explains Best.